My name is Francine Romine, and working with Sue Carney and Calvin and Katie, it's been a pleasure putting this symposium on for you, as well as a lot of support staff to make this happen. It is my pleasure to announce our next panel, UMTRI Impact, Perspectives on the Future. UMTRI has been at the forefront of advances in transportation safety for the past 60 years, but it's the future that we really want to talk about today. In this panel, UMTRI faculty will talk about the importance of interdisciplinary collaboration, advancements in modeling and testing, data collection and accuracy, AI, and what it really means by safety for all. This panel is moderated by Dr. Jason Hallman, Senior Manager for the Collaborative Safety Research Center at Toyota Motors North America R&D based out of Ann Arbor. He is responsible for technical guidance, administrative support, and people leadership for a multidisciplinary team of safety researchers. Please join me in welcoming Jason to the stage.
Thank you, Francine. If you did not get a chance to stand up in that brief period, I'm going to invite you to do that now. So I had an instructor years ago who used to refer to the time between 2 p.m. and 3 p.m. as the nap zone. So if you find yourself in the nap zone, feel free to stand. You can stand while I give the introductions to the rest of our panelists, including our panelists if you want. Absolutely. First, we have Dr. Jingwen Hu, research professor at UMTRI. Jingwen's research focuses on injury biomechanics in motor vehicle crashes using a combination of experimental, computational, and epidemiology methods. Next, we have Colleen. Well, I'm going all over the place, never mind. We'll do Colleen next. Dr. Colleen Peterson, assistant research scientist at UMTRI, is a social behavioral epidemiologist by training, and she applies advanced population-level analysis and mixed methods to examine issues of safety and mobility throughout life stages. We have Dr. Monica Jones, an associate research scientist at UMTRI, where her research spans human factors, vehicle occupant protection, engineering anthropometry, and human modeling for vehicle design, as well as ergonomics for consumer products and industrial workplaces. Dr. Arpan Kusari, assistant research scientist at UMTRI. Arpan's research interests extend through the spheres of sensing perception and decision-making for control of autonomous vehicles. And last, certainly not least, Dr. Renée St. Louis, assistant research scientist and the head of the behavioral sciences group at UMTRI. Renée has managed a variety of behavioral research projects aimed at enhancing safe mobility throughout the lifespan, including numerous projects addressing transportation issues related to the aging driver population. Did I get everybody? Okay, good. Quickly, during the break, or a previous break, I was talking to a few people who didn't realize that Toyota has such a large presence here in Ann Arbor, so I want to mention briefly that I am one of approximately 2,000 engineers, scientists, technicians, analysts working at Toyota R&D here in Southeast Michigan. We just recently celebrated our 53rd anniversary here, so we're not quite as established as UMTRI, but we're right behind, and they are one of the reasons why Toyota has established such a strong R&D presence here in Southeast Michigan. So I'm going to move over here like the other moderators for the actual discussion. All right, now I'm a moderator. From first, ground rules, there aren't any, so feel free to, panelists, first interact with each other. And second, if a question pops into your mind, raise your hand. I think this should be a conversation kind of atmosphere. And we're going to do our best on this side of the table to foster that. For our icebreaker, so we're here to celebrate UMTRI's 60th anniversary. In just a few sentences, what do each of you, panelists, think has been UMTRI's greatest impact on transportation safety in the past 60 years? We'll go down the line.
That's a really big question. But I was trying to think about it and think about it not just sort of within my group, the behavioral sciences group, but kind of across all the groups. And one thing I was thinking about is our impact on policy. And not just policy, but like safety standards, so SAE standards, rulemaking, policy. So particularly with my group, we've done a lot with graduated driver licensing, which was touched on a little bit earlier by Greg. We've done things with older driver licensing policy. We've done BAC policy, things like that. So I think at a high level, we've had quite an impact in the policy space.
Well, I have been working at UMTRI for only 18 years. It's long for my standard, but it's very short in terms of the history of UMTRI. So I don't think it do justice for UMTRI for me to pick one biggest impact. But if you think about the history, we have so many policy impact, standard, lawmaking. For the industry, general practice, design the car, also for the public, how to actually do things, and the public awareness. So I think if you tell me, ask me to say the biggest impact, I think the biggest impact is the diversity of the impact that UMTRI is putting on for the real world. And if you just want me to pick one, I think it will be in the next 60 years.
Oh, I like that. All right, I'm going to pick one, just to be different. And I think Henry touched on it this morning in his intro. So in the 80s, a large anthropometry study was done. So it was measuring anthro of body size and shape, not shape, actually importantly, body size of drivers. And that data went into what you now know as the ATD, the anthropomorphic testing devices, the crash test dummies, if you will. Pretty cool, because that's still being used today. So that was foundational work that was done that then we continue to evolve with. So foundational methods in terms of, and this Jingwen and I definitely, and Matt, we all collaborate, and Daniel on this space, quantifying body size and shape. Now we do it in 3D, right? Where we can get full parametric shape of that person and then create into more digital models. But it started with that initial 70s with children, 80s with adults, and it keeps evolving as the technology improves. And so really proud of that kind of seed of work that continues to pursue, and I think will continue into the next 60 years as well.
Thanks. I will go back to the trend of not picking one, and in fact go even broader as maybe a cop-out, but I think UMTRI has been really successful at not accepting the status quo of seeing those 40,000 deaths on the road every year and deciding that we can do something about it, not accepting that the roadway risks that we see are going to continue to be roadway risks for the next 60 years. And so we challenge that norm and we collect new data to inform the policy that Renee talked about.
So I've been here 5 years, so I'm 1/12 of the time that UMTRI has been founded. I think we sit at a nexus of industry, government, academia, where we inform all those three pillars, and that I think is our biggest strength, and why we can have the kind of impact that we can. And again, I do not know of all the different achievements that UMTRI has. Every day I keep on hearing something or the other. Sometimes, there are people in our group who have been here for 30, 35 years, and they keep on telling me about something that UMTRI has done that we now use regularly, and I do not know of that. So that's always very surprising. But yeah, I think that the position which we hold is very important to the general public. We present the policy, but we also inform the lawmakers, the industry representatives, and also the academia. We are trying to prepare the next generation as well. So that's very important.
Thank you. Several of our panelists talked about this. I think Jingwen mentioned it first, kind of the interdisciplinary nature of UMTRI. And so I'm going to ask, how can interdisciplinary research spanning engineering, human factors, data science, medicine, policy, be better integrated to address future transportation safety challenges?
No, you can.
We don't have to go down the line this
Yeah.
time. How about Arpan?
start?
All right.
Okay. Just changing it up. The best part about it is if we submit a proposal, even internally, people will ask, oh, you cannot submit from the same department. And I'll tell them, no, no, no. There is one person who is doing psychology. There is another person who is doing biosciences. Like I can walk 2 floors up and there's a person who is working on something which I have no idea about. And that's the best part about it, right? So any proposal that we get, I can walk up to any of these people and none of these people do what I do. And that's the best part about it. So in terms of being interdisciplinary, nobody, even in our same group, does the same work that we do. And if you think about other groups, that's more different than others, right? So that's our strength. And that's what I think was so revolutionary 60 years ago, to think of this as an institute where people could come from engineering backgrounds, from data science or statistical background, from biosciences, from human factor related work, behavioral work. So all of these people congregated to the same spot. And that I think gave the strength that it has to endure for this long.
And yeah, I'll add to that. That's my most favorite thing about UMTRI is how collaborative we are and how we have all these amazing brains under one roof. Yeah, from Arpan's background in engineering, mine's psychology and public health, and everything in between. And I can't think of one project where I don't have a collaboration, at least across groups. And then outside of it, we cross-departmental, different universities with industry, and so just as an example, at least 3 of us on this panel are working and representing 3 different groups, are working on a project right now that's focused on people with disabilities and how they can interact with in-vehicle infotainment systems, and using our collective backgrounds, I think it just really strengthens the product that's coming out. And if you guys want to say a little bit more about that, and how we've been able to work together to create, I think, something, it's originating in the biosciences group, but heavily related to public health and psychology, so.
Yeah, we've really worked on that project, the usability of vehicle interface design project, where each one of us it's sort of like a what do you call the race with the baton? A baton race, where
Relay?
Relay.
There you go.
It's a relay race, but instead of just literally handing off the baton, we're in a room together thinking about the problem from start to end, where we're talking to people living with disabilities about their issues, and then handing that information off to Monica and Kathy Klinich to help engineer the solutions to those problems that we identified.
Following that, another example, I guess, and I feel like we could pick any project, multiple examples throughout the Institute, but I study passenger motion sickness, so the notion that as drivers transform to passengers, there'll be a higher incidence, presumably, of motion sickness. And I love that multidisciplinary collaboration across the building allows us to approach that problem in such a holistic way. So I can look at, because honestly, we don't really have a good understanding of the etiology of motion sickness and how it manifests within a person, at least at a population level, to really mitigate it effectively. We can draw upon expertise. So I'm working, for example, with Huizhong on a human factors aspect, and Dewani with task performance. How do people interact with their devices? Is it relative to the cognitive load? I'm working with human factors specialists on the physiological monitoring of that, and can we quantify that? With my colleagues in biosciences on tracking, postural tracking, and head tracking. So it's just, and Colleen, we're going to work on the sensation, so how people report that, and how does that manifest across their time in a vehicle. So just a much more rich hybrid approach that you can take to a space and really have a much deeper understanding of the context of a problem that interdisciplinary allows us.
She's also working with me. She just forgot.
I
about
am. And Steve K on vehicle dynamics. I don't think I've got everybody yet, but it is the building.
I think when we talk about interdisciplinary, we are really talking about people.
Yeah.
People with different expertise. Well, you can have one person know everything, which doesn't exist. Or you can have a bunch of people that have different backgrounds. And I will call UMTRI as a melting pot for all the immigrants from different fields. Can we talk that? So it's such a different feeling that when you talk to people that have a different background, you can actually get inspired in different way, and suddenly you actually know what you don't know, which will significantly improve the innovation and research that we are doing. So,
Great comments. I want to springboard off a little bit something that Monica said about kind of all the data collection efforts that you were doing to talk about kind of data collection. We heard a little bit earlier in the day about like connected vehicles and infrastructure being coming soon or already here in some cases. As vehicles and infrastructure become this increasing level of connectivity, what are some of the challenges and opportunities in collecting reliable data for safety research? It needs to meet needs for accuracy, representativeness, and also respect privacy standards. Any thoughts there?
I can start, yeah, sure. And I need to be closer, I guess. So we're in a world of multimodal data. It's awesome. We can gather terabytes and terabytes of data, which is awesome, but we need to do it in a robust, accurate, calibrated, gold standard way. So one of the things, if you think of some of the work I do is, for example, driver state monitoring and that notion of taking over the vehicle in the event that the automation fails. Calibration just simply within the order of milliseconds matters, right? Is the driver effectively, relative to the CAN bus message that they've received the alert, are they effectively taking that over? So calibration, approaches, rigor, environment where you're testing really matters. I think when you're thinking about designing for something in the future, you need to be testing in that same environment. So yes, we want to do simulation, and yes, we want to do kind of expedited aspects of that, whether it's digital twins and such, but you also need that real world, ecologically relevant data collection too. So, you know, again, motion sickness, for example, studying it in a virtual simulator is not necessarily representative of that passenger in the vehicle on the road where you have different ambient lights and vehicle motion parameters that they're experiencing. So that ecological relevance really matters. And then I think one other aspect that I'll just touch on here, because I think it's going to come up in other aspects, is who are you studying? Are you studying people that you're actually designing for in the future? So I'll use motion sickness as another example, but we want to make sure that you're looking at people that do experience motion sickness and are susceptible to those who do not experience, so that when you're looking at solutions, you're not possibly disaccommodating anyone with any one particular thing. So, leave it to others.
We are in the business of data collection, so
yes.
Every other group and whoever wants data, you can come to us. So that's what we do, and the biggest challenge in that is not collecting data. It's before collecting data, it's how to plan for data collection, and we have staff who are much better than what we are, and they every day train us. That helps us a lot. So in that case, what we have to think is the optimized way of doing the data collection. That obviously is there, but also what kind of sensors are we using? How are we collecting that? Is there a way to kind of collect less than what we need, what we are thinking of, and still get it done, or do we have to collect more? So it's a matter of thinking through the entire process of data collection that begins right when we are when we have gotten a proposal. So it's not a matter of after we gotten the project, we start thinking about it. We start thinking through the process even beforehand. And that's where I think most of the privacy aspects of it and the cost effectiveness of it, how do we store that data, So all those kind of questions automatically come into the process.
Good point. As an epidemiologist, I'm also thinking about data from a bigger picture perspective, so not just collecting driver vehicle data, but I'm thinking about actual crash-related data. I'm thinking about enforcement-related data in order to help us answer questions, which seem straightforward. How does law enforcement affect safety outcomes? Getting the answer to that question is a lot more difficult because that data isn't quite available as you would think. I'm working on a particular project that I am collecting stop data and citation data and crash data and also law enforcement activity data from as many states as possible. And that means for every kind of data in every state, there are different formats and different data types that are collected, and basically asking individual agencies if they would please share that data with me. And it's a challenge. So to that point, I think circling back on some earlier themes about making data-driven decisions, it's hard to make those decisions and have them be data-driven when that data isn't there. And if it is there, it's not available to us. And what is there is not uniform or consistent. Like thinking from a systems-wide perspective, we need to be thinking about standardization, availability, and I had another word for there.
Baton race?
Yeah, baton race. Transparency, centralization, and standardization would make safety-informed decisions and policy that much more effective. And the way it is today, at least in terms of the data that I was talking about, there aren't as many carrots and incentives to bring people together to make those decisions. And there are some standards out there, MUC, I completely forget what that stands for, but basically it says you should collect this data in your crash data, but there's no real enforcement mechanism to make sure states do that.
We've got a question from the audience. You said they could raise
Yes,
their
that's
hand.
right. Anytime. Go ahead. Thank you.
Yeah. And so I think actually, while the mic moves over to that, there was an issue about, enforcement must have some sort of impact on impaired driving. We'll find out. We'll find out. But answering that question is a little more difficult than you would think.
Thank you. As I'm listening to you talk, Alice Taylor, Los Angeles Maritime Institute. I'm in the maritime industry, so a bit of an outlier here. But we're a nonprofit, we're always worried about funding. Your $100 million ask from this morning. As I look at your perspectives for the future, how do you avoid a situation where, we'll use AI in particular, sexy new technology, and you have much more funding pushing that in the organization, and how do you keep it from overwhelming your other interests? Because you've got this long legacy as I listen to these other projects, and you don't want to lose that longevity to suddenly have it be cut out. So could you talk a little bit about your funding model? Is it 30% grants? I mean, what are you willing to share, I guess, because it's something I deal with every day, and I think the audience would like to hear this.
Well, our funding model is we are fully soft money, meaning that all our salary has to be covered by the research funding. Okay, so that's very clear. So we rely on the industry and government funding to support our research. But at the same time, the unique part of us is that we do have our long-term vision, that we will innovative the technology, the method, the data, so that we can push let's say, transportation safety, for example, moving forward. So I guess we need to actually have a conversation about that. And I don't think the $100 million is a joke.
No.
You can laugh about it, but that's real. And this is actually, I think, 60 years is a turning point of the institution. And I think we should really seriously think about the next step and how we actually move this research institute forward with real-world impact. And we can continue to do what we have. We are good at it, but at the same time, it's great to actually think about the next big target.
I would like to add, I probably do quite a bit of AI, but again, AI is a tool just like in calculator. It's not going to, it's going to change how we do things probably a little bit, but it's not going to sufficiently alter us from what we have been doing. So most of the projects that are there will still remain because the problems will still remain, AI or no AI. So I don't think that will sufficiently alter. It's just a tool, right?
So, hi, I'm Simrat Kaur. I'm an AI/ML strategist. So, I have a question on Colleen was talking about collecting the data and issues you guys having, with structure of the data. So, when this AI started, the data was the biggest issue. Thanks to you guys, doing your job every day, collecting that data. And my question is, so when you collect that data, how do you validate how good that data is? And do you have any issues, do you collect metadata to validate that? And
That's a really good question. A lot of the data that we rely on are crash police reports, and we trust that police are writing down the information as best they can. We know that they're in a stressful situation and often doing the data reporting afterwards because they've got to focus on other things in the field. So we kind of know that it's not completely accurate, but just like talking to any person about what their perspectives are, we take it with a face value knowing that there's a little bit of a wiggle room on the edge. But the more data we collect, the smaller our confidence interval can be around that. Yeah.
Is it a percentage threshold?
Oh, I wouldn't want to put a number on that. Yeah, we're collecting as much data as we can. And I think, actually, can I jump off of your point and talk about, AI might be a great tool to collect data and look at, but it's really still in the hands of humans to decide how to collect that data and how to share that data. So there's always going to be that human element that we interface with.
I just want to add that I don't think AI is going to solve all the problem. The people use AI going to solve the problem. And UMTRI is doing a lot of AI-related research, but just look at us. I think the domain knowledge is very, very important to properly use AI and leverage AI to move the transportation forward. I think that's important to know. Yeah.
Yeah, and data validation is a gnarly problem, no matter where you go, because you can sometimes do a quantitative job, and that could be good enough. But if you are looking at any high-dimensional sources, cameras, images, LiDAR, point clouds, something which has lots of things to look at, it becomes very difficult because even people, if you tell two people to label the same thing, they will label it somewhat differently. So then you get 10 people to label it and then try to find out how many of them agree on that, right? So it's kind of similar.
Yeah, what is that ground truth? Especially the human diversity piece of that and the human factors of that is highly variable. So quantifying it all and understanding that, we still are understanding that, right? So.
And to add to that, so Colleen and I are mixed methods researchers, so we do a lot of qualitative data collection, so a lot of talking to people and hearing in their own words what their perceptions, say just what their perceptions are of, for instance, the safety of autonomous vehicles. And then it's like, what do we do with that? How do we validate that? But it helps to complement the quantitative data and tell a more complete picture of the story.
Do we want to keep talking about AI? I have a question on that. Or we could just go to kind of jumping out that first question about maritime and kind of transportation systems more generally. So transportation systems broadly provide great service to our society. But as we know, society is actually made up of many individuals with different body sizes or health conditions or abilities and needs. How can future safety research better account for this variability to maximize safety and benefits for all?
Can you start?
Sure.
That's my research topic, basically. So I would like
And mine.
to start, I think. All of us, yeah. I think to account for those variability, we have to quantify those variability. And I think one thing that maybe you know, maybe you don't know, that do you know that the vehicle crash safety design is based on the mid-sized male only? Maybe a little bit of small female, but the small female is 5'11" and 100 pounds. You don't know anyone is on that size. So it's basically driven by the mid-sized male. So if you're not a mid-sized male, you're unlucky. Can you imagine that? You're paying the same money for that vehicle, and in a crash, your injury probability is higher than the mid-sized male. Is that fair? I don't know. So the question that we're addressing is that just to make sure that we have equal opportunity, to make sure that everybody have sufficient protection, and make sure that everybody is considered into the design process. I don't think that's a lot of things to ask. But the history tells us, and we only design the crash safety designs based on mid-sized male. So our research through the years really is to quantify the human variability, and by looking at the variation of human size and shape in terms of body shape, but also the skeleton, the bones. The data collection is important, and at the same time, we are using those data collection and using different statistical method and computational power to build the tools to be able to evaluate different injury risk for different people. So we have the state-of-art technology that I think UMTRI is the first one to actually have this technology to say, if you tell me your age, gender, stature, BMI, we can predict the model just for you. And that meaning that we can actually put those human body model into the vehicle safety evaluation and make safety for all as a reality. But I don't think it's enough for now, because that needs a whole field collaboration, including the industry, the government, and also the public to push for that direction. I think safety for all is not just an academic concept, is for the whole industry. We have to understand why we are doing that, and we put all the efforts into that.
Probably further to that is the project that Renee mentioned about the UVID, so the user vehicle interface design. In that particular project, we're looking at disability types, and importantly, not looking at conditions or pathologies that people may be labeled as, but looking at their functional capabilities in a real ethical way in terms of their interaction with the vehicle, and in particular with the interface. So it's physical abilities, whether that's range of motion, cross checks to mirrors, and looking at the ability to ingress, egress from the vehicle or don your belt, relative to fine motor skills in terms of being able to actuate the different interfaces on the HMI of the vehicle, to cognitive and how they understand the HMI information that's being conveyed to them, whether it's someone with neurodivergence or an elderly person with maybe different aging dimensions going on. So and then there's vision and there's hearing. And so we've actually, with that project, created a construct where we're not binning people necessarily into any one bin, because often many people present as many different abilities and disabilities, if you will. And so being very inclusive with that and ensuring that the design meets all of those continuum of needs to ensure safety again. But that's just one project. I think absolutely all of our work touches on this aspect of variability.
I think we all try in our projects, those that are working particularly with human participants that are live.
We're doing cadaver tests,
yeah.
that's why.
But we tried to create some diversity within the people that we're surveying or speaking to about certain topics. I mentioned earlier, I do a lot of work in the aging driver population. So even in just this cohort, there's so much variability. What makes an older adult an older adult? And we talked a little bit about policy, and so there, in some places there's age-based policies for older adults and licensing, and trying to think through, like what Monica was talking about, sort of the functional aspects of a person as opposed to chronological age, because there's so much variability. So these are all things that we try to keep in mind and ensure that we're sort of tackling the problems from different perspectives and getting all the voices at the table to ensure that people are heard, and that the solutions that we're coming up with are actually applicable to more parts of the population than just that 50th percentile.
Everyone has spoken? I try to stay away from humans as much as possible.
Audience question.
Thank you. Since this is a perspective on the future, and Toyota, you guys are doing the advanced research, we spent pretty much the whole day looking at ADAS and machine interface in vehicles, red light, cross-section, all this kind of stuff. Do you see the future 20 years from now where we bypass every car, every bus, everything we know today, and we go to drones? It's more or less virgin territory, right? It's free. You know, the air, quote unquote, is free, right? There's no road, there's no infrastructure. And yes, we have airplanes flying at 30-some thousand feet up there. We know today we can fly 3,000, 5,000, 8,000 drones, right? And nothing touches anything else. If you're looking at the future, are you looking at these kind of things, or gonna solve the ADAS problem before we get to that stage?
In 20 years, no. In the future, probably yes. And I'm pretty much sure that UMTRI will doing drone research at that time. So the research topic will evolve based on what we are thinking in current status and then what we're thinking in the future. So you can see 50 years ago what the research we are doing, and 50 years later what we are doing right now is definitely evolving. And we are probably doing the research 10 or 20 years ahead of the current status. So that's kind of the vision that we have. But don't you think that drone need an ADAS system as well in 3D? And that's really a legit question. And I think for any kind of innovation that is coming to us, and we need to think very carefully on what the outcome it is. And I think UMTRI's research just set the foundation for that.
I have a question. How do you know that those 8,000 drones will not crash into each other?
It's pre-programmed, right?
Yeah, so, because they have been programmed together to not crash into each other. But if they're not talking to each other, they're crashing into each other.
But remember, before a drone goes up in the air from your parking lot or your driveway, you're going to say, I'm here, I want to go there. And you are given a route, and we know where every other drone is. The important bit is that we have the whole UMTRI here looking at the future. So I just want to get your perspective.
So it's a connected and autonomous vehicle at that point, right?
Right.
So we are working on that.
Yeah, that was kind of my question. Are you looking that far down the road?
You solved the data sharing problem in the future. That's great.
Yeah.
Like your view on just the V2X space. Obviously some OEMs have backed away from earlier commitments, and having been active in this space personally since 2008. It's been a long road, and we just wonder. Intuitively we see advantages, of course, V2X seeing over the horizon, and be able maybe to deal with some problems and merge with AI. Maybe we can get it's kind of the data and intelligence that helps us deal with some intractable use cases. Mm-hmm. So, is there any hope there, is my question.
I think it's just a winter, like a lot of winters. AI has passed through one winter. We don't know whether the second one will be coming or not. But V2X, I think, is going through a similar kind of winter. I thought people got really excited about connected vehicles. And at some point, that did not come to fruition because I think the infrastructure wasn't there to support it. But I think at some point, I think connected vehicles will come earlier than the automated vehicles because it's a simpler problem at that point if we have the infrastructure in place. So I believe that, yes, we will see a resurgence just because of the stuff that we have talked about the safety aspect of it. It just gives an easier way of safety, right? So, yes.
Follow-up question. Real quick. UMTRI's been very active, of course, in the space. Can you give us an update on the Smart Intersection project? I know that's been one of your big projects.
But I'm not the one heading that. I believe Henry is the one heading that, and I think he'll be able to give you an update. Thank you.
Maybe follow up in a little bit later about that. I do want to kind of springboard off of that question and ask anything from the behavioral side with regard to connected and automated, specifically, for example, like a low-hanging fruit would be like in-vehicle advisories, right? Like messages about traffic jam tail or weather or something that the driver would otherwise have to take action on. Any thoughts or activity on that?
I don't have any current projects that are that directly related. Most of the projects I've been involved in are looking at trust and acceptability in ADAS technologies from mostly the older adult perspective. And what we're seeing is so we've asked nearly 3,000 older adults about the vehicle or the technologies they have in their vehicle, but then also had a research assistant go outside and look in their vehicle to see exactly what technologies they have on their vehicle. And so many of them did not know that they have these technologies on their vehicle. So from that perspective, we know that there needs to be something done about training and education for people. How can we best teach people about the types of technologies that they have in their vehicle that should keep them safer? Another thing, I was thinking about this, another one of the panels earlier, well, AI has been talked about a lot, but specifically autonomous vehicles. There is this really massive collaboration of a project that involves many, many people in the room, Michigan, M-City, or UMTRI, M-City, ACM, the City of Detroit, Deloitte, May Mobility. So we have this project where it's focused on older adults and people with disabilities and their use of an autonomous shuttle service in Detroit. And our job, the behavioral science group, followed 300 of these people that were eligible to ride the shuttle. And what we did see was that over time, we followed them for a year. Some people rode the shuttle, some did not. But what we found was that their trust and acceptability and reliability and how they felt about AVs did increase over time, so that was great. But then we looked at the qualitative data because we had some open-ended questions, and we were like, what did you like about the service? Oh, it was great. I really loved the safety driver. I loved having conversations with them. They were great. I really loved, they would help with my groceries. Like, it was still this human element that was that was like really driving their participation in this shuttle service. So I thought that was really interesting. But as we think through all these new technologies, trying not to lose that human element because it's pretty important.
Francine, how are we doing on time? Oh, all right. You heard that? She's deciding to eat into the next break. All right. How about with the growth of computational capability and the concept of digital twin, what roles do we see with physical testing versus computational modeling or simulations, especially in the next decade with regard to safety research? I'm going to start with Arpan.
I see the role as increasing of simulation just because of the feasibility aspect of it. We cannot do everything in simulation. Especially funders love to have that. Can you do all in simulation? No, we cannot. We have to do the data collection, at least some of data collection, so that we can know what to get from simulation. But the simulation aspect of it is really important because it gives us something to start off, and also the edge case aspect of it. I think in one of the previous panels they talked about you cannot, especially for things like AVs, you cannot like look at every corner case that there exists, but we can simulate those. And the realistic simulations of those kinds can really help us in building those and robustifying those models. So that's where I see a lot of the computational modeling going, and it'll go more and more towards cases which were previously deemed high dimensional and were not being simulated. So stuff like camera images and learning from camera images, those are the cases which we are getting into and we'll be getting into more and more.
I think it always needs to be a blend. I mean, I don't think that's ever going to go away. And Wembo spoke quite eloquently to this in the previous panel, that we need that baseline physical data acquisition at the beginning to really anchor in reality what the situation is. Then in simulation, we have the ability to move into those edge cases, but then we need to come back to that verification again to ensure that we really have effectively captured. And importantly, when it comes to the human, because how do we even know that we've effectively quantified that distribution of human response to, say, an autonomous vehicle takeover or something to that effect? I mean, you've got so many different signals coming at you, but have you gotten to that ground truth of the reality of how some people respond how they respond in different ways, and how do you quantify that variability? So I don't think there'll ever be a place where we completely negate the physical testing. I think it's going to be essential.
Just add on that, I think virtual testing is a very popular concept in pretty much all the transportation world. In the crash safety world, we're talking about in the future, US NCAP gonna still do all the physical testing and get the star rating. You go to the dealer, you have the side window and have the star rating. That's the physical test with mid-sized male and small female dummy. But for virtual testing can be complementary to that, because in the virtual world, we can build human body models not only covering mid-sized male and small female, but also all the range of different occupants. That's the physical testing cannot do. And physical testing is expensive as well. They only crash in high speed. They don't crash in the low speed. Just think about those conditions are totally missed by the physical testing. We can definitely do some virtual testing to actually be complementary to the physical testing. And in the future, you could actually find a car that you input your weight and height, for example, and then it will give you a star rating for you. I think that's the future that I see that is very much achievable as a virtual testing being very much complementary to the physical testing, but at the same time, give you more information and to be more adaptive and also safety for all. That's probably one of the example as well. But the one thing I do want to mention is that in the virtual testing or modeling world, there's a question very similar to how safe is safe question, is how accurate is accurate enough question. I do think that especially when you talk about a diverse set of human body model, how are you exactly going to validate those models? You can't validate every model. You have to use some stochastic approach to sample the space, make sure that it covers, you kind of validate the trend and how that compares to the field performance. And those are all very legit academic questions that we are trying to put things together and address those as a whole. So those are very important. I think there are questions there.
Hi. So my question is on simulation. So are you guys using regular simulation tools, or are you using any kind of machine learning or any of artificial intelligence integration along with the any simulation tools?
Depending on the project and topic and field, for sure. Just take my field as example. We are doing crash simulations. And of course, we have to have specific tools for crash simulation, and that's more accurate. You can't blindly put machine learning model on top of that. But at the same time, all those simulations will take time to run. You can't run unlimited number of simulations. So there's definitely a room to say that machine learning, once you run enough simulation, you can actually use the machine learning to predict the things that you haven't run and make it faster and things like that. That's actually the major utility that we're using. I don't think that's a new concept. I think people start using that maybe 20 years ago already. We call that response surface model, and right now we call that machine learning. But at the same time, it's the same concept. Yeah.
So are you implementing just the prediction model, like at some places like I would say head injury impact if you are testing? So are you using simulation along with some kind of machine learning prediction, or are you using large language models? Or what kind of technology are you using for artificial intelligence there?
I think we can find another time to talk those into details. Yeah, we use all kinds of different methods, for sure. And actually, large language model, believe it or not, actually have a utility to actually do the accident reconstruction and things like that. So there are different applications of different methods. So we can take other time to actually talk in more detail, I guess. Yeah.
And I want to jump in kind of to the other side. So I don't do any of the things that Arpan and Jingwen do, but I think I think there are benefits and applications to simulation work for training and education, and having people, especially new in their driving experience, who haven't experienced all those edge cases or been in all the driving scenarios, have them experience driving and potentially dangerous situations in a safer space. I conducted a study featuring virtual reality and had participants, teenagers actually, do a game called Virtual Navigator, where they drove a spaceship kind of to simulate driving, but not too much so they don't gamify it, with and without distracted tasks. And when they did the distracted task, they crashed and created a lot more harmful outcomes. And actually, in talking to them about that, they understood the analogy between their driving this virtual reality game to their driving on the real road, and saw, oh yes, really started to internalize the dangers of distracted driving.
Now I'm curious, did you follow up with that group to see, like, did they actually have a change in crash or citations?
This is going back to the $1 million question. This was a small pilot study, and we only had basically before and after study pilot data. So yes, next steps are to do a larger study to follow people over time and get their actual real world data. I will take your money, thank you.
Toyota want to fund it?
We'll talk more offline. We got just a little bit more time left. If there's any more questions from the audience, otherwise I have kind of one wrap-up question.
Well, I have a question.
Yes.
Give me your thoughts on this concept of safety for all, and what is your vision for what that means for your expertise and the type of research and the people you want to work with to really drive that home? And that was not a plant question. I'm genuinely.
I want to know. Do you want to go Renee, or go ahead, I'll start. Go ahead. Okay. Okay, I'll start. So in my biosciences hat on, safety for all is very much the aspects of the passive and the active safety features within the vehicle, so looking at restraint features. So then it's body size and shape and morphology of a person and how they sit in the seat, where they sit. Importantly, looking at use cases, because I think as we push into the future, our use cases are changing as the driver is no longer actively needing to monitor the scene ahead. We have some non-nominal seating postures, presumably, where people are engaging in their devices under certain ODDs. And so really effectively understanding where they are relative to the active restraints, whether it's the airbags and such in the vehicle. So there's that hat, but then there's also my other hat of comfort for all, so safety and comfort for all, because now the experience of driving is, yes, safety first, of course, but also how are they experiencing that ride if they're no longer actively driving? And so then I'm thinking of things like motion sickness and occupant monitoring and what it is that they are doing in the space so that they can effectively use their time as they want in that space, but then also be available in this conditional automation space that we live in now, where they can still effectively come back into the loop and be effectively able to re-engage with the driving. So it's a really broad continuum of safety for all, and we have to be inclusive of that entire population. So 13 undergrads in a study is not going to cut it. We need to really sample the population that will be in the vehicles in the future.
Yeah, and I'm thinking about it from a public health epidemiological perspective, where I'm really taking the systems level approach. I think the word safety culture has come up a number of times, and thinking about safety culture from every level of the socio-ecological model, to throw that jargon at you, thinking about safety decision making at the governmental policy level that affects human actors, human decisions, but also infrastructure. What kind of infrastructure do we have in place, and can we make it safer to get us to the ideal of Vision Zero, which is 0 deaths on the road? Other countries who have more of a safety culture, a buy-in and process from top to bottom, have been making progressive success on that goal, and the US sort of lags behind.
Follow on from that, I'm also a fan of the socio-ecological model and sort of systems thinking. But to take a little bit of a different point of view, I know I said I was all about the aging population, but I also about the little ones too. So I'm a certified child passenger safety technician instructor. And so I do a lot of boots on the ground work in the community. And so you kind of see a lot when you're out there, and you want to ensure that every kiddo is going home safer than they arrived. But I can extend that thought to kind of everything we're doing. So again, it's the solutions that we're coming up with. Are they accessible for everyone in the population? And to be able to do that, to Monica's point, is to be able to be more inclusive with the people that we have in our studies, the things that we're learning from people, just to ensure that, we think we're doing good, but let's make sure we are.
From the engineering perspective, it's the engineering features that we put in our vehicles and how to make that, because everybody who is driving a car, how can we make them safer? And in that, how do we design those features, the safety features, better, more robust? Essentially, for ADAS features, the problem is that they are pretty narrow. They are for a certain kind of perspective, so can we broaden it out? So that's the kind of safety for all that I can think of, because then you can also think of the pedestrian who is walking or the bicyclist who is taking they are also part of that same environment, and they probably, if they get hit by that car, they're not surviving, or sometimes they're being badly injured. So can we actually also make it safer? So PED A, B, or some sort of design features like that, safety features like that also help. So that's what I think of when I think of safety for all.
Just maybe very quick, safety for all the people means people with, also means people with this different health condition. And we do a lot of wheelchair study just to see how they can safely travel with different disability conditions and things like that. That's part of the equation as well.
I think that's a great note to leave everybody with. We're out of time. Please join me in thanking our panelists once again.